Hi, hello, welcome to Dr. Zahid Maths. How are you all? Welcome to module 3 of differential equations. In this video, we are going to learn how to find eigenvalues and eigenvectors of a 2 by 2 matrix step by step. It's an important concept used in many real world applications, especially in engineering and systems modeling. Let's keep it short, clear and easy to follow, right? Let's begin. So the first question comes in your mind, where this eigenvalues and eigenvectors are used in engineering. First of all, it is used in stability analysis. It is used in stability analysis of differential equations. This is the first place where we are using this one. And the second thing, solving systems of linear differential equations. So to solve a linear differential equation, which is systems of linear differential equation, we will use matrix idea. Linear differential equations, which is systems, which is equations, right? Okay. Then mainly in electrical engineering, we will use in control systems. In control systems, lot of places we will use matrices to differential equation to matrices. Like this, we will be changing the ideas. The next thing is in mechanical systems, we will use in vibration mode. In vibration mode also for mechanical systems, we will use this one. Okay, right. So very important thing, the latest thing in data science, right? This is the latest application. Everywhere we see data science and artificial intelligence. In data science, what we do with this matrices, we use principal component analysis. Principal component analysis. In short, in computer science, we call it as PCA. For PCA purpose in data science, we use matrices. Okay, right. Then what about the next main idea? After finishing this eigenvalues and eigenvectors, we will use the same idea to diagonalize a matrix. Mainly we are studying this one for diagonalization purpose. Okay teacher, where we are going to use this diagonalizing operators in quantum mechanics, you know very well, right? In quantum mechanics, we use this diagonalization process very well. So for all these purpose, everything covered in eigenvalues and eigenvectors. Okay, right. So what is your eigenvalues and eigenvectors? Before that, let's go small introduction about a matrix. What is a matrix? A matrix is a rectangular array of numbers. You know, right? We are going to arrange like this, right? It's a rectangular array of numbers or functions. Matrices or matrix enables us to consider an array of numbers as a single entity, right? And thus occur in a wide range of engineering problems. For examples, as the many things which I told you, the coefficients of a system of linear equations, right? Now, eigenvalues and eigenvectors. What is eigenvalue? What is eigenvector? For eigenvalues, you need to remember, suppose A be a square matrix of order n, then the nth degree equation. The nth degree equation is called a characteristic equation. The nth degree equation is called as what? Characteristic equation, which is given by determinant of a minus lambda I is equal to 0. A is the given matrix and lambda is the scalar and I is the unit matrix. Okay. What is unit matrix? If it is 2 by 2, 1, 0, 0, 1. If it is 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is a 3 by 3 matrix. Okay. So first we are going to find out this characteristic equation. Once you solve this characteristic equation, you will get lambda values and those values are called eigenvalues. Those values are called eigenvalues. What about eigenvectors, teacher? Eigenvectors, we are going to give it as a formula again, right? Okay. Any non-zero vector, keep in your mind, any non-zero vector, right? Keep underlining any non-zero vector x, okay, such that matrix A minus lambda I times x is equal to 0, right, is called the eigenvector of A corresponding to each lambda, right? Or you can say another word also, latent vector. Eigenvector also called as latent vector, or another word, I think covariant vector also you can call. Covariant vector, or you can call it as characteristic vector also you can call. Like that, characteristic vector also you can call, right? All these vectors are corresponding to each lambda value, right? I hope you understood, but going like this is not easy for you. I know you all like step by step. What is step 1? What is step 2? Step 3, right? So what are you going to do in step number 1? Step number 1, you are going to find the characteristic equation. What you are going to find out? You are going to find the characteristic equation, right? What is characteristic equation? For a 2 by 2 matrix, you are going to write the characteristic equation lambda square minus beta 1 lambda plus beta 2 is equal to 0. For a 2 by 2 matrix, again I'm telling, for a 3 by 3 matrix is different, okay, right? For a 2 by 2 matrix, it is lambda square minus beta 1 lambda plus beta 2 is equal to 0. So we need to find this beta 1 and beta 2. What is beta 1? Beta 1 is called as sum of leading diagonal elements. This beta 1 is called what? Sum of leading diagonal elements. And beta 2 is called determinant of A. Or you can write also like this, determinant of A. So this is step number 1. So step number 1, after you finding beta 1 and beta 2, you are going to put this beta 1 and beta 2 in this equation. So you will get an equation in lambda square, right? So once you get an equation lambda square, then use mode 5, 3. Then you will get lambda 1 and lambda 2. So this is called eigenvalue. This is called what? Eigenvalue. Again, I'll repeat. First step is you need to find the characteristic equation. What is characteristic equation for a 2 by 2 matrix? Lambda square minus beta 1 lambda plus beta 2 is equal to 0. What is beta 1? Sum of leading diagonal elements. What is beta 2? Determinant of A. So right? Yes. After finding beta 1 and beta 2, try to put it in the equations. Then you will get a quadratic equation in lambda square. So after that, you go to the calculator, mode 5, 3. Then you solve it. Then you will get two values in the calculator. That values are called eigenvalues. Right. Step number 2. Right. What is step number 2? Step number 2 is you are going to find out eigenvectors. You are going to find what? Eigenvectors. Right. So what is the formula for finding eigenvectors? Just now I told you, matrix A minus lambda I times x is equal to 0. Matrix A minus lambda I times x is equal to what? 0. X is a column vector. Keep in your mind, x is a column vector. How much it is given? Capital X equals, if it is a 2 by 2 matrix, I'm going to call it as small x1 and x2, right? So when the situation comes, I'll tell you how to find eigenvectors. Keep it as a formula, right? How many eigenvectors will come, teacher? For each lambda, you are going to get eigenvector. Okay, it means for a 2 by 2 matrix, how many lambda value will come? 2 lambda values will come. So for each lambda, you are going to get what? 1 eigenvector. So it means for a 2 by 2 matrix, you will get 2 eigenvectors. Okay, right. So let's go to the first question. Okay, right. So the first question is given by find the eigenvalues and eigenvectors. Let's go to the first question, which is question number 47, right? Find the eigenvalues and eigenvectors. Find the eigenvalues and eigenvectors for a given matrix, okay? A is equal to, it's a 2 by 2 matrix, okay? Minus 1, 2, and then minus 7, 8. This is the question. So let's start the solution, right? So before starting the solution, I'll go back to the step numbers and we will do it. Only 2 steps. First step is what? Finding eigenvalues. What is step number 2? Finding eigenvectors. Okay. Step number 1. So first thing is you're going to write what? Characteristic equation, right? You're going to write what? Characteristic equation. It is a 2 by 2 matrix. How you call it's a 2 by 2 matrix? 2 rows and 2 columns are called what? 2 by 2 matrix. So the characteristic equation is lambda square minus beta 1 lambda plus beta 2 is equal to 0, right? Okay. What is beta 1? Beta 1 is equal to sum of leading diagonal elements. Leading, okay? Sum of leading diagonal elements. I told you how to see the leading diagonal in the previous video, Gauss elimination method, right? If you didn't watch that video, please go back to that video, watch it and come back again. What is your leading diagonal? First element in the first row, second element in the second row, third element in the third row. That is called as leading diagonal. Okay, right? So what's your diagonal here? It's minus 1 plus 8, which is going to become what? 7. So beta 1 is equal to 7. Right. Let's go to beta 2. Beta 2 is equal to what? I said determinant of A. Some people say it's absolute value. It's not absolute value. Determinant A. It's a 2 by 2 matrix. You can easily calculate by mind. But if not, if you are not able to calculate by your mind, just use calculator. How? Just give this matrix in the calculator, and after giving the matrix in the calculator, you're going to calculate det of mat A. If you give in the calculator det of mat A, you are going to get 0. You're going to get what? 0 or not? No, not 0 in this question, sorry. Det of mat, I thought some questions I worked out in the class, I thought 0. Right, det of mat A, you can get it from the calculator. Let me work out here. Minus 1 into 8, which is minus 8. Minus 1 times 8 minus 7 times 2, right? Minus 7 times 2, which is equal to, this is minus 8. Okay, minus of minus is going to become what? 14. So it's going to become what? 6. So beta 2 is equal to 6. Let me put it in the equation. So lambda square minus beta 1 lambda plus beta 2 is equal to 0. So lambda square minus beta 1 is how much? Which is 7. So 7 lambda plus 6 equal to 0. Now go to your calculator, mod 5 but then 3. So if you go to the calculator, lambda is equal to what? 6 and lambda is equal to what? 1. You get 2 values because it's a quadratic equation, so you'll get 2 values. Right. So lambda is equal to 6 and lambda is equal to 1 is called eigenvalue. Right. Okay. Now we are going to find eigenvectors. Step number 2. Right. Step number 2, we are going to find what? Eigenvectors. Right. Eigenvectors are given by the formula what? Matrix A minus lambda I times x is equal to 0. Let me explain this. After that, you forget this idea. You can go with shortcut. What is that? A is the matrix, right? What is the matrix A? Which is minus 1, 2 and then minus 7, 8, right? And then minus lambda times I said what? 1, 0, 0, 1 because it's a unit matrix. And then times x1, x2 is equal to what? 0, 0, right? So what happened to this one? You're going to multiply first row with the first column, right? Before that, you take this lambda inside. Minus 1, 2, minus 7, 8 times. Take this lambda inside, you just put it plus minus lambda 0, 0 minus lambda. Why? This lambda comes here 1, lambda comes here 1 times x1, x2 is equal to what? 0, 0. If you solve this one, what will happen now? The things will happen minus 1 minus lambda and this will be same, no change, and this will be no change, minus 7, and this will have a change 6 minus lambda, right? 6 minus what? Lambda, you will get it. So close it and then you will get x1, x2 equals 0, 0. Now look at this. What is the final answer I got? I got the final answer changes only in the terms of what? In the place of diagonal itself. So no need to write all these things in your exam or in your classwork notebook. So just keep in your mind, whenever you are going to calculate eigenvectors, just write the changes happens only in the diagonal. So what I'm going to write, this is your matrix, okay. So in this matrix, I'm going to write directly minus 1 minus lambda and then 2 minus 7, 6 minus lambda. From where I wrote this one? Your matrix A is this minus 1, 2, minus 7, 8. This is your matrix A. Just put here minus lambda. Put here minus lambda, right? 8 or 6, I'm not clear. Minus 1, 2, minus 7, 8. So this is minus 7, 8. This one, sorry, this is 8. Okay, this is 8. Okay, 8 minus lambda, right? Minus 1 minus lambda, 2 minus 7, 8 minus lambda. So times x1, x2 is equal to 0, 0. You call this as equation number 1. Because why I'm calling this as equation number 1? Because for each lambda value, I have to come here and put it. Okay, yeah, right. So let me start case 1. Right, let me start case 1 and let me start case 2 here, right? Case 1, I'm going to put lambda is equal to the first value, you got it 6 in equation 1. So when I put lambda is equal to 6 in first equation, what I will get? Minus 1, here I'm going to put 6, minus 1 minus 6 and then 2 minus 7, 8 minus 6 times x1, x2 is equal to 0, 0. So this equals, I'll get the answer minus 7, 2, minus 7, 8 minus 6 is 2 and this is x1, x2 is equal to 0, 0. So I'm going to make it as an equation which is minus 7x1 plus 2x2 is equal to 0. Minus 7x1 plus 2x2 is equal to 0. Every time, most of the time you remember, you will get identical equations. Identical means what? Same equations you will get it. Okay, keep in your mind. What is my job? My job is to find x1 and x2, right? Okay. So what I'm going to do now, I take one equation, minus 7x1 plus 2x2 is equal to 0. Always try to find out what is x1 equals. Always try to find what is x1 equals. So let me start doing this. Minus 7x1 is equal to, this goes that side, which is minus 2x2. So when I divide by minus 7, what happens? I will get x1 is equal to 2 over 7x2. This is the equation I get. Why, teacher, we are finding equations? Because we are going to find out x1 and x2, which is the column vector, which you are going to get it. Okay, right. So how we are going to find out this x1 and x2? Keep in your mind, you can choose your own values for x2, irrespective of any values, but you shouldn't get, it should be a non-zero vector. Keep in your mind. Okay, right. So what I'm going to do, I'm going to choose x2 is equal to my choice. I'm going to choose 7. Teacher, can I choose x2 is equal to 1? Yes. Can I choose x2 is equal to minus 1? Yes, no problem. 2, 3, 4, minus 5, minus 6, anything you can choose, right? So if I choose x2 is equal to 7, what happens to my x1? 2 by 7 times 7. So you get what? 7. So x1 is equal to, I get what? 2. So x1 I get 2 and x2 is equal to, I get what? 7. So this is your first eigenvector x1. Clear all of you? Very easy. Let's go to case 2. What is your case 2? You're going to put lambda is equal to what? The next value 1. When I put lambda is equal to 1, let me write here. Put lambda is equal to 1 in equation 1. This is your equation 1. Okay. So let me put here minus 1, and then 2, minus 7, 8, minus 1. Operating on x1 and x2 is equal to 0, 0, right? This is minus 1 is minus 2, and this is 2, and this is minus 7. 8 minus 1 is going to become what? 7 times x1, x2 is equal to what? 0, 0. Now some of you can think, teacher, can I use calculators for solving these two equations? If you use this, you will get error because the right hand sides are 0. See here, constants are not there, right? So what happens to my equation? First row, first column, right? So it will give you what? Minus 2x1 plus 2x2 is equal to 0. One equation is enough. If you want to write, you can write 2 also. Minus 7x1 plus 7x2 is equal to 0. Both are same equations, which is called as identical equations. How do you know, teacher, it is same? Look here. Minus 2x1 plus 2x2 is equal to 0. So if you cancel this 2 and 2, minus x1 is equal to what? Minus x2. So x1 is equal to what? X2. Take the second equation. Minus 7x1 plus 7x2 is equal to what? 0. So minus 7x1 is equal to minus 7x2. Minus 7 gets cancelled. So x1 is equal to what? X2. So automatically same, right? So both are identical equations. Identical equations means what? It is same equations. Okay, right. So let me take the first equation, right? Minus 2x1 plus 2x2 is equal to 0, right? So this is equal to minus 2x1 is equal to minus 2x2. I divide by minus 2, I divide by minus 2, which implies x1 is equal to x2. I told you all the time, try to get x1 equals, right? Now I'm going to choose x2 is equal to what? 1. Easy value, right? Don't choose 0, 0. 0, 0 should not come. Eigenvectors are non-zero vectors. Keep in your mind, right? So what happens now? We are going to write capital X2 is equal to small x1 and x2. What I choose for x1? It is 1. And x2 is equal to what? 1. So this is my first eigenvector and this is my second eigenvector. So you're going to represent your answers. How? So eigenvalues and eigenvectors. Write eigenvalue and then write eigenvectors. Okay, right. What are the eigenvalues you got it? Eigenvalues you have got it is two values you got it. One is lambda is equal to 6 and second one is lambda is equal to 1. And the first eigenvector is 2 and 7 and the second eigenvector is what? 1 and 1. Clear all of you? Right. So in this way you are going to represent your answers. So this is your eigenvalues and eigenvectors for a 2 by 2 matrix. It is clear all of you? Clear or not? Right. So it's very simple. So great job finishing this video. If this felt easy, that's a win. You have understood the basics of eigenvalues and eigenvectors. In the next video, I'll move on to eigenvalues and eigenvectors for a 2 by 2 matrix. But the values which I'm going to get are complex values. Okay. These are all real values. Okay. Right. Don't forget to like the video, share with your friends and subscribe to the channel if you found this helpful. And see you in the next class. Take care. Bye bye.